Good morning, ladies and gentlemen. Today we are going to continue with chemical equations. Today's focus will be the different types of chemical equations, okay? There are 5 total that we're going to be looking at. This is not the same presentation that's been posted already. This one is going to be posted along with the assignment. I don't like 100% the way they go over the chemical reactions in there. They make it more complicated than it has to be. So I'm going to use this one instead. It focuses on the exact 5 that we're going to go through. Okay. So the 5 reactions we're going to be looking at are synthesis reactions. Synthesis is when you're combining things. Okay. So synthesis is when you're combining stuff. Decomp or decomposition is when you're breaking things down. And then you have single displacement, double displacement, and combustion. Okay. And combustion we've seen previously, but we're going to go through it more in depth. So synthesis reactions. It is when 2 simple substances combine and form a single compound. And this is the general formula. A plus B makes AB. Okay. So what is an example? A and B can be anything, but another one, one we commonly look at is water. Blue is not coming up too well, so let's not use blue. Okay. So let's say we had hydrogen. Hydrogen can be A. Oxygen is B, and you combine them together and you make H2O. Okay, and that'll be your AB. This is an example of a synthesis reaction. So in synthesis reactions, you're combining 2 smaller things and making something bigger. Okay, that is a synthesis reaction. And here they have that exact same example. Okay, hydrogen and oxygen make water. This is synthesis. You have carbon and oxygen, and that makes carbon dioxide. That is also a synthesis reaction. Okay, so these are examples of synthesis reactions. You're combining 2 smaller things to make something bigger. That's your indicator that it's synthesis. Then you have decomposition. Decomposition is when things break down. So you start off with a compound. You can use the water example again. So we start off with H2O, and then we split it into H and O separately. This is decomposition. Decomposition is when you break things apart. Okay, that's decomp. And they're probably going to use, they're going to use the exact same examples. Water and, well, this time they're using mercury and mercury oxide is what this is. So AB goes to A plus B. Okay. Water is being broken apart into hydrogen and oxygen. And that exact process is actually called electrolysis. Okay. If you were wondering what it's actually, how they actually do it. They do it with electricity. It's a common way to do it. Then we get into the realm of single replacement. Single replacement or displacement, as they had it earlier, is just when a compound replaces another one in a kind of like a buddy system, and basically somebody's getting kicked out the group. Think of it like that. So initially you have BC. Okay, let's say you have BC. B is attached chemically to C, and then you have A. For some reason, C likes A more than it does B. And so what happens is B gets kicked out, and now B is by itself, and now you end up getting AC. Okay? So for some reason, then there are chemical reasons, C likes A better, so then B gets kicked out, and then you have A attached to C now instead of the B. And you call this single replacement. Okay? And this is the general formula, and here's an example. So these are just some things to look for, because today's work is just going to have you look at chemical equations and see which type of reaction it is. And what you should be looking at is for these general formulas and seeing if the structure is more or less the same. So here, let's call iron A. Okay, in this one, let's call iron A. Copper is B. And then the SO4 is C. Okay. In this case, what's getting kicked out? What's getting kicked out is the copper. So then you end up with A being attached to C, and you have B by itself on its lonesome. Okay. And you can do the same thing here. Mercury, or that's not mercury. Mercury is Hg. Magnesium is your A. Let's make hydrogen B and the chlorine C. What's getting kicked out? What's getting kicked out is the hydrogen. So then now you have A attached to C, and you have B by itself. So this is what you call single replacement, okay? They're trading partners. Whatever is by itself is the beginning is going to be attached to something in the end, okay? And something is going to get kicked out. That's single replacement. Then you have double replacement, which is where you just trade partners. That's all that's happening is you're trading partners. Okay, so A, B, C, D, you end up getting C, B, and AD. Okay, so what is happening is the B and the D are trading spots. Okay, for chemical reasons, reactivity, they are trading spots. That's all that's happening. They're trading partners. That's what double replacement is. Let's look at an example. Okay, let's call this is A, B, C, and D. And then after the swap, you end up getting AD and CB. All that's happening in double replacement is they trade partners. Okay, they're trade partners. In single replacement, you have somebody swooping in and kicking somebody out. Okay. And in double replacement, everybody already has a partner. They just decided to trade partners. That's double replacement. And then you have combustion. Combustion reactions generally all look the same. The only thing that will change is the fuel, and the fuel is the hydrocarbon. Okay. Combustion reactions are always going to have something with carbon reacting with oxygen, and it's always going to make CO2 and water. Okay. So this is what you want to look for. For this last one, if you see this, automatically combustion. If you see the oxygen and you're making carbon dioxide and water, boom, clear sign. This is a combustion reaction. What can change is the fuel, okay? So the thing in front, this is your fuel. You can be burning different things. You can burn gasoline, you can burn oil, you can burn candle wax. Like there's a bunch of different things that you can burn. But the burning process is always the same. You need oxygen and then you make CO2 and water. This is a combustion reaction, okay? But the thing circled in yellow, this is your fuel. Your fuel can change, but the combustion reaction is always the same, okay? And they have it here. This is the part that can change, but you're always going to have the oxygen and you're going to make carbon dioxide and water. But the part in the fuel in front, that can change, okay? But that's all a combustion reaction is. Combustion is just exactly that. You're burning or exploding something, okay? And it requires oxygen, fuel. So you need the fuel, you need your oxygen, and then you make carbon dioxide and water, okay? This is what's happening in engines. This is what's happening whenever you light up a barbecue, anything. This is what's taking place. Okay. So those are your 5 reactions. Okay. Those are your 5 reactions. There's more in the presentation that you are more than welcome to look at, but this is what I wanted to focus on. Okay, just these 5. Okay, so these are the 5. So synthesis, again, you are bringing 2 smaller things together and you're combining them. Decomposition is the opposite of synthesis. You're breaking things apart, okay? So let's write out the general and just a little quick summary. So this synthesis is A plus B makes AB, okay? You combine them together. That's synthesis. Decomp is the exact opposite. You have AB, and you're breaking that into A plus B. You're breaking it apart. Single displacement or replacement, it's the same thing as when you have somebody, a single lone individual kicking out another chemical from its partner. So let's say you have A plus BC. This is now going to make AC. The A kicked out the B. Now you get AC and you have B by itself. Okay? Double replacement is the same thing. I'm running out of space. I'm not going to write double replacement. It's the same thing, except instead of A being by itself, let's say A now has a partner. Okay? And then you do a swap. Okay? That'd be the only difference. You're trading partners. So single and double are basically the same. And then combustion is going to be some fuel. X is the fuel. Doesn't matter what it is, but it's some sort of carbon-based fuel. Plus oxygen is going to make CO2 and water. Okay. Okay. Now let's do some examples from the sheet. I'll do a couple. There aren't that many reactions, so let's do a couple. Okay. So today's work just has you classifying the reactions. Are they single, double, synthesis, decomposition, or combustion? Okay, let's look at one. What is happening in one? I have one single element here. One single element. Let's call that A. What's going on? Okay. Plus another single element B. And they're being combined together. What does this look like to you? What type of reaction does this look like? Go back to the slides. A plus B makes AB. This looks like synthesis. Okay. So number one would be synthesis. Okay, number one is C. Well, let me not label that C. Matter of fact, because I'm gonna need that letter. Okay. So number one would be synthesis. Okay. Let's look at number two. One single element, sodium, plus another single element is making a combination AB. So number two would also be a synthesis reaction. Okay. Number three is also synthesis. Let's do another one. Okay. Number four. What's going on in number four? What do you see in number four? Number four, you should know what it is right away if you look for the key sign. If you see this, automatically you should be thinking what? If you see that, you should automatically be thinking combustion. Okay. Remember, combustion is always going to have this. If you see this, oxygen, and you make carbon dioxide and water, automatically combustion. Okay. So number four would be combustion. Okay. This would be C. I'm going to put COM for short. Okay. Now they start to get. I'll do one more because obviously I don't want to do all of them. Let's do one more. Let's do this. So you want to label, my recommendation, label individual elements. Okay. And then see what's going on. So I have a single chlorine, or not a single, it's in pairs, but that's chlorine's my first element. I see sodium. I see bromine. It's attached. So right now I have A plus BC. And then what are we making? Sodium's my B, but now it's connected to A. So now we have BA plus C. So what happened here? What happened is A kicked out to C. A kicked out to C. And now A is partnered up with B and C is by itself. What does this look like? That to me looks like single replacement. Okay. This is a single replacement reaction. Somebody partnered up and they got kicked out. This is a single replacement reaction. Okay, so 8 would be single replacement. I'm going to just put SR for short. Okay. So that's it for today's work. I think it's a bit easier than what we've done thus far. You're just matching, making sure that you understand what type of reaction is happening. Okay, different metals, different elements react differently, and generally speaking, those properties, well, they impact a lot of different things, and we'll learn more about those in the future. But that's what today's work entails. Just categorize them. What's single, what's decomposition, what's combustion. For combustion, you're just looking, if you see oxygen, carbon dioxide, and water, you know it's combustion automatically. But that's it for today's work. Okay? Hope you guys are doing all right. I wish you the best. And as always, if you have any questions, feel free to reach out.